So now we'll proceed further, testing some other graphs. For this, we just I just messed it out. So we have this. We do the vertical line test. So for the value of 1x, we're getting only one y. Anywhere you can draw a vertical line and test whether it's a function. So basically, what we discuss is कि if एक x की वैल्यू के लिए हमें सिर्फ एक y मिल रहा है, that is a function. And in case of graphs, consider if we have a graph, this like, so when we are at a value of x, it's certain x, when we do the vertical line test, line parallel to x-axis, y-axis, line parallel to y-axis, we getting only one value for one particular x, then this is a function. It can be any function, right? Consider let fx is equals to x cube. So how is the graph of x cube? X cube graph is like this, right? So we have only one value for one value of y for one value of x, one value of y for one value of x. We have x here, y here, so only एक x के लिए हमारे पास सिर्फ एक ही y पे वैल्यू है. लेट्स सपोज -5, लेट्स सपोज दिस इज -2. -2 के लिए सिर्फ -5 ही मैप होगा. दिस इज कॉल्ड मैपिंग. बेसिकली एक मैपिंग एक प्रोसेस है where we just draw like two circles like this, and this is called the domain and this is called the codomain, and this is a function. So let's suppose we have this function is called fx of x cube, right? This is a function of x, which is x cube, so 1 2 3 until n, and we have here the codomain. We can take anything 1 2 3 4 till n. So 1 corresponds to 1, so we have the cube. So 2 corresponds to 8. Now I should tell you that 3 corresponds to 27 here somewhere, because it's natural numbers, right? Positive number greater than 0. So uh, 1 only corresponds to 1 and 2 only corresponds to 8. 2 is not going to correspond to 27. That is not a function. We have defined that x cube is a function, fx is equals to x cube is a function. Then we have to consider a thing that if this is a function, then it have only value of this, we are going to have only one value of y. For one value of x, we are going to have only one value of y. Now proceeding further, this is not a function, because when I cut, let's suppose this, so it's cutting from many places, it's continuing forward also. So this is not a function. For this I draw the vertical line test. This is a function, this is a function, right? Now we will discuss more further about it. So this question says, for which of the following y is a function? X belongs to r, y belongs to r. So we are giving r to r function, right? R to r means here that range is in the r and codomain is also in the r. I should tell you that codomain codomain is a superset of range, right? And range is the subset of codomain, right? Range is the subset of codomain. That, I guess the sign was wrong, pardon. uh, so I should write range is subset of codomain. Basically codomain is greater than range in terms of element. It can be equal to also, it can be equal to in case of one-to-one functions, which we will study later. But right now we are saying that codomain is greater than or equal to r in terms of, let's suppose if we are considering the cardinality, right? Then we have this function. So basically I can sense that this function just forms a you know this forms a circle, because the equations is the standard equation of a circle. Considering like this, this not let's suppose here comes h comma k, then here is a circle. So for one value of x I have two values of y. Anywhere I have uh, one value of x, I have two values of y. So this is not a function, definitely. This is not a function in x. Then we are considering this x power 4 equal to y square, right? Then we just take the value of y, which says us that x power 4 k power 1 by 2 is equals to y, so which gives us x square equal to y. So it is a function. Y is equals to x square is a function, as if we draw the function of this. So we have but pardon me for this. So this is a 2-degree equation. It will also have minus x square equals and plus of x square. So this will also give a function like this. So if it attach the vertical line, I can get I'll get two values of x. This is not a function definitely. This is also not a function. And for the 3y equal to log x square, it says 3y equal to, right? So y is equals to log square x by 3, right? So this is definitely a function. How I can just draw the graph of log x and then its square. uh, Basically log x graph is like this. So if I square it, right, it's not going to much do, but dividing it by any constant, it will not change the value, it will not change the terms of in terms of variables, right? So it is a function. Then we are getting y is equals to 4ax. 4ax, basically this is standard equation of this parabola, but this is not a function definitely, because we are getting double values of y for a single value of x, right? So this is not a function definitely. Then we get this value, x power 6 by 3 plus minus equals to y. So this gives us plus minus x cube y. So I get like this. The graph will look, its graph will look like this. I'll just draw it here small. So its graph will look like this, a positive, and this the negative. So basically when I do the vertical, oh shit, sorry, pardon. I'll just do the vertical line test, and while doing the vertical line test, I'm able to see that there are two values of y for a corresponding x. So this is not definitely a function. Just not a function, right? So we are completed with this. Now we have moved to next question, which says let gx be a function defined on -1 to 1 if the area of equilateral triangle with two of its vertices at 0 comma 0, and x gx is root 3 by 4 square units. The function of gx may be. So basically it says gx function here defined on this -1 to 1 area of equilateral triangle. Considering this, let's suppose we have let's draw the coordinate system. One vertex is on the 0 comma 0, right, and this one vertex is here at this, right? So just gx is a function. Let's suppose gx is here and we have x here. So gx is a function considering we have the value of x for here. So this these are the function, these are the vertices, right? So what we are going to do is area is given as root 3 by 4. Basically let's suppose this is x, right? So every part will have the same side because it's given equilateral triangle. So area of equilateral triangle is given by, I'll just erase it and write the actual formula for equilateral triangle, and it says root 3 by 4 a square. It's the area of equilateral triangle. So if I consider x, so root 3 by 4 x square will give me root 3 by 4, and this cancels out and it gives us x is equals to plus minus 1. So basically as x, we all know that x is not a type of thing. So we just I'll just discuss it later. This question has to be completed by me alone, right? I'll just do it later, right? Represent diagrammatically all functions, all possible functions from alpha to beta 1 to 1 2, right? So whenever we write in these curly brackets, we mean that individual elements, not in the interval. For interval we basically use these type of brackets, but when we use these curly brackets, it says it's only one or discrete numbers. I should say in mathematical language it's called discrete numbers. So if I have written this a b, this is not this, like if it's a, this is b, this is not like in the interval line between this. No, this is not this. This is just a and b. It's only A and B, not this. It's not an interval, right? How can I write this? I'll just do the mapping. So basically we have alpha, beta, and 1 and 2. So for function to be defined, fn function, so we have alpha to be alpha, we can get this, or we can get this. We can get alpha s2 and we can get this. So how many functions are there? We have only one function, two function, one function, two function. Only four functions are there, right? For every corresponding value, we have to the power 2. We have 4 number of functions from f a1, a2, a10 till b1, b2, b5. So we have a1, a2 like this function till a5, a10, sorry, and we have b1, b2 till b5, right? So a will corresponds to one value because for functions to define, x will tends to only one value, but y can be corresponding to another values too. Be corresponding to b. A10 can also correspond to b. That's the different case for one-to-one function where only one element maps to only one unique element, but that's not we are talking about right now. We are just talking about the functions to be defined. So how it works? Basically, we say that the codomain, basically codomain we have, and the this is the domain, right? So what we say that A has possible combinations of five, right? We have five, and for the b a2 we have five, for the b a3 we have five. So